Hi friends, how are you? In this video clip, I am going to brief you on disperse dice. See, early I released one video on disperse dice, part 1. See here, introduction to disperse dice. Dice are, that is textile dice are, the class of dice can be studied in deep with many lessons, with many volumes. But the thing is, for students of diploma in textile technology or BTech in textile technology or MTech in textile technology, whatever the course offerings are there, for those students, the limitations, that is also in 10 to 15 minutes videos, maximum 20 or 30 minutes videos we have to cover. We have to give brief idea. Okay, in the past, please watch my first video, part 1 on disperse dice. I gave introduction. Now next, this part 2. In this video, I am going to brief you, introduce you about the chemistry of the disperse dice. Friends, please subscribe to my channel. Actually, my channel, I changed the name. It was Guruvira Textile and Fashion Technology was there. Now, because of the now present, what the education trend is there, most of the institute provide, offer the courses as in terms of fashion technology, not in textile technology. Instead of fashion technology are growing more, openings are more. Okay, in that textile subjects are there. In that textile subjects are there. Separate textile units, colleges are reducing nowadays. So I am also changing my channel name as Guruvira Institute of Fashion Technology. That is GIFT, gift. Okay, like NIFT, like other things are there. In this channel, I am going to give some classes not only on textile parts, even on fashion, clothing, merchandising, marketing, fashion marketing, and other things. Whatever the subjects involved in fashion technology, including merchandising, marketing, that plan I have to take cover in this my channel. So friends, please subscribe my channel, encourage me, okay, to move further in this online classes. So my channel, please subscribe to my channel, Gift Guruvira Institute of Fashion Technology. In future, I will come videos with other fashion technology subjects. Okay, okay. Chemistry of dispersed dyes. Chemistry, you know, friends, direct dyes, reactive dyes, basic dyes, acid dyes. Okay, and many sulfur dyes. Okay, all these dyes have their specific own chemistry. Like that, dispersed dyes also they have some chemistry. In this, see, what are the characteristics? Some characteristics are there for dispersed dyes. Some dyes, friends, soluble in water, that is dissolve. The whatever solution is there, dissolve in water. Say direct dyes. Direct dyes dissolve in water. Wet dyes, okay, not wet dyes. Some basic dyes, okay, those are soluble in water. The character, if you add powder form of the dye in the water, that will dissolve in the water like sugar in water. But some dyes, they will not dissolve in water. They will not dissolve in water. The manufacturer of dyes, they make them to dissolve by the help of carriers, by the help of chemical agents, to dissolve in solutions, so that that dyed solution can be applied on the fabric, or the fabric can be dyed with that solution. See, the dispersed dyes available in the market, the characteristics are they are not dissolved in water. We have to make them to dissolve. Absence of solubilizing groups. In the dispersed dyes chemistry, in the dye molecule chemistry, whatever dyes are the dye molecules are the chemicals chemistry. In that dyes solubilizing groups are not there. The groups which are responsible to dissolve in the water. Those groups are not available in the dispersed dyes. Friends, dispersed dyes first used to dye acetate fibers, next tried for polyester fibers. Okay. First this dye is discovered, innovated because to dye acetate fibers. Okay now. So solubilizing groups are not there. This is one point. Second one, low molecular weight or size. Molecular weight of this dyes and size are very less. Okay, compared to other dyes, molecular weight means the weight of the molecular weight, but very lighter disperse dyes. So because of the lighter, these are the characteristics. Lighter weight. These are used for the polyester. It's a good sign to dye polyester, that is man-made fibers. Man-made synthetic fibers, low molecular weight dyes are very helpful. Then dye fiber interactions. How dye fiber interaction takes place? Affinity between dye molecules and the fiber polymer structures. How? How it is? In case of direct dyes, in case of bad dyes, direct affinity will be there. Direct attraction will be there. The dye molecules are attracted by the surface of the fibers. Okay, na? Attract cellulosic fibers in direct dyes. And in case of acid dyes or basic dyes, there is ionization, ionic in nature. The reaction is ionic in nature. That is anion and cation. That ionization reaction takes place to create affinity between the dye molecules and the fiber surface. That is fiber substances. That is polymers. Okay. But in case of reactive dyes, chemical reaction takes place. Chemical reaction takes place and bonds, covalent bonds, van der Waals bonds. So those are the reactions. Chemical bonding, chemical reactions take by reacting by chemical reaction, dye fixed on the fiber surface or on the fiber molecules. But in case of how in this case dye and the dye molecules and fiber, how they uh, how they attracted, how they made them to attract, how to fix the dye of the fiber surface or its inside structure means by hydrogen bonds. This is one hydrogen bonds. Hydrogen atom of the dye. In the dye molecules, there is hydrogen atoms in there, and oxygen and nitrogen atoms of the fiber. In the fiber molecules, oxygen and nitrogen will be there. Those oxygen and nitrogen atoms of the fiber react with the hydrogen atoms of the dye. React with the hydrogen atoms of the dyes. So this is one method of dye-fiber interaction. That is chemical reaction. This is called chemical reaction. Oxygen and nitrogen atoms available in the fiber, and hydrogen atoms available in the dye. And second type of interaction, how they dipole and dipole interactions. This is dipole electrostatic interaction between dipoles of the dye molecules and polarized bonds of the fiber. This is dipole of the dipole. This is electrostatic interaction. This is one type of chemistry, dipole and dipole interactions. Electrostatic interactions. That is absorption. That is affinity. Attraction takes place by the dipoles. Dipoles of the dye molecule and polarized bonds on the fiber. This is one type of chemistry is there. Okay, based on the dipole, this is one. Make them to attract. By anyway, the task is dye has to go and sit permanently on the fiber. Okay now. And van der Waals process, aromatic groups of the fiber and colorant of the dyes. Fibers, aromatic groups. Okay, benzene ring and other things are there in the chemistry. Those aromatic groups of the fiber and colorant of the dyes. Particular dyes, blue color, red color, whatever colors are there, those colorants are react with the what is aromatic groups of the. This is three types of bonds interaction method of or way of making dye fiber, that is dispersed dye to go and sit permanently to fix on the fiber, not only on the surface to the the internal. Then only the fastness of the dye will be good. The fastness of the dyes based upon the percentage, the amount of dye fixed on the fiber. If the dye is not fixed properly, then whatever the fabric dyed is there, no, that fabric has low fastness. That color gives low fastness, means it will bleed out. So the thing is, what is required? The dye molecule has to go inside the structure of the fiber, in the morphology of the fiber, and fixed permanently. Lock. The dye molecules are to be locked within the polymer or morphology of the fiber. Okay, now, then only the dye molecules will not come even at even in washing, even exposed to sunlight, or even rubbing and other things. Even fabric rubbed with any other second material, the color should not bleed. That is, rubbing fastness should be good. And if it is washed, uh, color should not bleed. That is wash fastness, laundry wash should be good. If it is the fabric is that fabric is exposed to sunlight for a long time, the shade, the color should not fade. That is good light fastness. Okay, now, so for good fastness, the fixing of the dye in the on the fiber surface as well as inside the go and lock inside the fiber surface is required. Like this. Okay, now, but it is not possible in all the cases. So international standard ASTM and other standards of the global standard, they are permitted for some kind of dyes, for some kind of fiber fabrics. That will come in the textile testings. Or you can watch in my other videos or the color fastness videos I made. More videos we have made in the textile technology. Okay. Now, see, this is about the chemistry and also fastness properties. How the fastness properties, whether good or not. Then, even though this dispersed dyes are dyed on the polyester fibers, so light fastness is good. Light fastness means the polyester or acetate fiber dyed, dyed fabric. If that dyed polyester even exposed for a long time to the sunlight or heavy light, the color will not bleed. That is grade is fastest grade is 4 to 5 there. And also wash fastness is moderate 3 to 4 there. Even you can also see polyester fibers or even nylon usually bleeding in the wash fastness is not there compared to cotton. Okay, so fastness property of light fastness wash fastness are good. Now chemical structure, this two examples I give how the structure of the dispersed dyes appear in the chemistry. This looks like this is the chemical structure of the monoaldehyde. This is one of the dispersed dyes. And then anthraquinone dyes. This is one of the structure. See, I told you in the first period these are what are other compounds, dispersed dyes and anthraquinone. Mono, the whatever dispersed dye is available, 50% of the dispersed dyes contain azo compounds. Content of the dispersed dyes are different. Some dispersed dyes contain azo compounds, some dispersed dyes contain anthraquinone, and some dispersed dyes contain nitro and naphthoquinone and methyl. So, no, don't think that only one kind of dispersed dyes are there. Many kinds are there. Dispersed dye content is different. Mono is there. Some monoiodide is one of the content of the dispersed dye, and other content is anthraquinone is there. Okay, this like that, different are there. And think in my first class I told uh, not all dispersed dyes are approved by the international level. In case of RSL testing, restricted substances list, some chemicals are banned. Some dispersed dyes, some class of dispersed dyes are totally banned to use in the textile industries. Though the list of chemicals, the list of dispersed dyes which are banned, those are toxic in nature, and not it is hazard to the human health as well as the environment. Some few dispersed dyes, those are approved and they are used in the market in the industries. What I am talking here is in the class that is which are permitted, okay, not banned. Okay, now this is one thing is that okay. Actually, I will not close this video. I will complete this first dice. Okay, so that I will take next class another subject. Auxiliaries. See in the process of dispersed dye in the process will be the dyeing process of the dispersed dyes. What are the what it includes? Auxiliaries are required to dye a fabric. For material to licorice will be there. For this much of meters of the fabric, this much of dye is required. This much of quantity of fabric, this much of quantity of color is required, dye is required. That is material to licorice will be there, and chemicals dye is available in the form of powder, in the form of liquid also. That is one point. And also, I told you one more thing is there. One more thing is there. Important in case of dispersed dyes is dyeing of the polyester fabric. Dyeing of the polyester fabric is not easy by using what discuss this. Here I'm going to here I mentioned where I mentioned the thing I will tell you temperature maintenance in the dispersed dyes. Here it is not there. The point is not there. I forgot to mention it. Temperature. Okay. Carriers. Carriers are used. What are those carriers? What are dispersants? What are thickness? What are the reduction agents? These are the four, and some other uh, auxiliaries are used other than disperse dyes to dye a fabric, polyester or acrylic or nylon by disperse dyes. Other than disperse dyes, the other chemicals required are dispersants are required. What are those dispersants? That is additional in lacquer and washing. Dispersants are the coloring agents. Dispersing coloring agent. Those are also dispersed dyes. Material to lacquer ratio. For 100 meter of the fabric, 50 gram or 1 kg of dye. Example I am telling. This is not. I am not an industrial expert. For 100 meter of example is for 100 meter of dye. For 100 meter of fabric to dye 100 meter of fabric. Say example 1 kg. Example 1 kg of dye is used. But if that material liquor ratio will not help when the fabric is dyed and dried, as per the material to liquor ratio, the required shade has to be achieved. Say pale yellow or pale green or pale pink color. That is for that shade, how much material to liquor ratio is calculated by the engineer, textile engineer. But that material to liquor ratio, as per that calculation, that shade to be achieved. But at the end of after drying, finishing, that shade is not achieved sometimes. Little bit this color is required. So to manage that shade, at the time of washing or in the liquor, in the middle of the process or during the end of the process, additional colors, additional dispersing color, disperser means that is extra color is added to reach the required shade. That is dispersing agent. And second one, carriers are required. Carriers. See, for below 100 degrees centigrade dyeing temperature, important for polypool blends. See, this dispersing to dye a polyester fabric, temperature is required. How much temperature is required? 90 degrees centigrade, 99, 100, 110, 120. You see friends, for dyeing by dyed dyes, sulfur dyes, reactive dyes, bad dyes, any other dyes, maximum the dyeing temperature, okay, how much it is there? 60 degree, 60 degree, 45 degrees to start, it will start 45 degree to 60 degree, maximum 70 degree. But in case of to dye without carriers, without adding carriers, it will take more, more temperature required to break up dye molecules and enter into the fiber structure. To break up the dispersing dye molecules and to enter into the fibers, polyester fiber structure, to react with the polymer of the polyester structure, it is required temperature is required, and the high temperature required, and also high pressure is required. High temperature, high pressure required. That's THP to dye. That is up to 120 degrees centigrade. But if 100% polyester fiber is there, that's okay. 100% nylon is there, that's okay. That fiber, that is synthetic, man-made synthetic fiber that can withstand the temperature because fiber is tenacity is maintained in the man-made fibers. But if if that polyester is blended with the wool, if that polyester is blended with the viscose, what will happen? Polyester can withstand temperature more than 100 degrees centigrade, but wool will not withstand. Wool will damage. If viscose is there, viscose will damage. So what is required? What is required? To maintain for that wool, for that viscose, temperature 100 degree, below 100 degree centigrade is required to maintain. For that, carriers are used to break up the dye molecule. Next, carriers are the extra agent, chemical agent used to dye blended fabrics, that is polyester wool blended, polyester viscose blended. Okay, for that carrier are used to maintain below the 100 degree centigrade temperature. Okay, now hope you understood. Carriers are required to maintain temperature less than 100 degree centigrade. If carriers are not used, then temperature required is more than 100. Pressure is also required. High temperature, high pressure. STSP is used in case of this polyester dyeing. 100% polyester dyeing. And also thickness are used. Polyacrylate thickness to make what will happen? Always thickness are required. See, thickness in case of other class of dyes, whatever the paste, the dye is there, that is even dyeing takes place. Because the dye itself creates a thickness. The paste thickness will thick will be the dyes. But in case of dispersed dyes, it's a thinner. Sometimes what happens while dyeing, unevenness, chances of unevenness dyeing chance is there. So to avoid unevenness, okay, what will happen during the padding? Thickness are added. Thickness that is polyacrylate and or allanate added in the dye liquor during the padding process. In the padding process, to hold dye molecules each other evenly and spread evenly, gum-like thickness added that will take care of leveling of the dye. Okay, so thickness are required. Otherwise, disturbance in the thin, if it is thin is the dye, then some part of fabric takes a dark and some part of fabric takes light shade. Okay, to maintain even shade, thickness are required. Then reducing agents almost used in many cases, very nice, mainly sodium hydrosulfide in final washing. Even for sulfur dyes, reducing agents are required. For other dyes also, reducing agents are required. And after dyeing is completed, when the fabric comes to washing, the final washing, mainly sodium hydrosulfide will reducing agents. This is common. Okay, this is about the process simple. If you want, you can go through the books. Okay, this is just what in the small 20, 30 minutes video, how much we can explain. Only the story we can tell. So you can refer many books out there. You can refer in deep. Okay, step by step. Okay, one more last item. Disperse dyes in the commercial names. Just thousands of market in the market, thousands of market is there. There is manufacturers are there in each and every country wise. So example I'm giving in UK, ICI, that is Disperse, or their brand name is Disperse, the ICI brand, and in Netherlands, foreign Kindos, in Italy, Textile Acna, in Germany, Cameron, Onyx. These are their country-wise, they are manufacturing brand and there. And in suppose in Indian companies, examples, Huntsman International is there, Huntsman International India Private Limited, Indochem is there, Asiatic other chem industries is there. So, friends, this is about the chemistry. Just a brief this introduction I gave you. This you can consider as the part 2. Okay, next. This is English is there, but for Indian students, Hindi also required. So one video on make or dispel that in Hindi. Okay, next video will be released in Hindi. Okay, so friends, please subscribe to our channel. Gift Govina Institute of Fashion Technology. Okay, please don't confuse my old name. Now the trend, education trend is that in fashion technology, once upon a time, textile technology was there. Textile technology subjects are becoming a part of clothing technology, that is fashion technology. Keeping that point in view, I changed my channel name GIFT, like NIFT, not NIFT, GIFT, Gurvira Institute of Fashion Technology. Please subscribe to my channel and like it and share it. Please click the icon bell to get the notification in your devices. Thank you very much. Thank you.